Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.94. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. Ohm's law will also be utilized while solving this problem. According to this law, voltage across any resistance R is always equal to the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.94. Find the value of current IA in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of this constant current source labeled as IA. So without wasting time, let's proceed towards the solution. First of all, voltage across this 2 ohm resistance is provided, so we will calculate its current. Current equation for this 2 ohm resistance will be 4 volt divided by 2 ohm. It will become 2 ampere, and the direction of current will be downward because in order to make this terminal positive, current should enter from this side and leave from this side. So modify the network by indicating current through this branch. Here, because of series connection, this same current with same polarity will also flow from 4 ohm resistance as well. So after knowing the value of current through this 4 ohm resistance, we can calculate voltage across this resistance. That will be equal to the product of current and the value of resistance. So voltage across this 4 ohm resistance will be 8 volt. And polarity notation of voltage across this 4 ohm resistance will be positive terminal here and negative terminal here because current is entering from this side. Modify the network by indicating voltage across this 4 ohm resistance. Now in order to calculate voltage across this 3 ohm resistance, we will apply Kirchoff's voltage law inside this closed loop. For that purpose, we have assumed the direction of current in clockwise direction. Start writing KVL equation for this closed loop. Start from here, current entering terminal is positive, so 4 volt will be taken with positive sign. Next, current entering terminal is negative, so 6 volt will be taken with negative sign. Next, voltage across this 3 ohm resistance will be taken with positive sign because current is entering from positive terminal. And at the end, current entering terminal is positive, so 8 volt will be taken with positive sign. Now add 8 volt and 4 volt together, it will become 12 volt, and subtract 6 volt from 12 volt, it will become 6 volt only. And place this 6 volt on the other hand side of equal to calculate voltage across this 3 ohm resistance, that will be minus 6 volt. This minus sign along with the value of voltage is indicating that we have taken wrong polarity notation across this 3 ohm resistance. The actual polarity notation of voltage across this 3 ohm resistance is opposite to the assumed polarity. So modify the network by indicating right polarity notation across this 3 ohm resistance and the value of voltage as well. 6 volt with this polarity is appearing across this 3 ohm resistance. Now we know the value of voltage across this 3 ohm resistance, so we can calculate current through this 3 ohm resistance. That will be equal to 6 volt divided by 3 ohm. It will become 2 ampere, and the direction of current will be downward because in order to make this terminal positive, the current should enter from here and leave from here. Modify the network by indicating current direction through this branch with its value. Now 2 ampere current is coming from this branch on this node and 2 ampere current is coming from this branch on this node. So their accumulative current will be flowing from this branch in downward direction. The sum of 2 ampere and 2 ampere will become 4 ampere and the direction of current will be downward in order to justify Kirchoff's current law on this node. So modify the network by indicating current through this branch with its direction. 4 ampere current through this branch is flowing in downward direction. Now we will apply Kirchoff's voltage law inside this closed loop to calculate voltage across this 2 ohm resistance. For that purpose we are assuming the direction of current in clockwise direction. So start writing KVL equation for this closed loop. Start from here, current entering terminal is positive, so 6 volt will be taken with positive sign. Next, current entering terminal is positive, so 6 volt will be taken with positive sign. Next, current entering terminal is positive, so voltage across 2 ohm resistance will be taken with positive sign, and at the end current entering terminal is negative, so 6 volt will be taken with negative sign. Now add these constants together. This minus 6 volt will cancel out with plus 6 volt and the equation will become 6 volt plus V2 ohm is equal to 0. Place 6 volt on the other hand side of equal to calculate voltage across 2 ohm resistance, that will be minus 6 volt, and here again minus sign is indicating that the polarity notation across this 2 ohm resistance is wrong. So modify this network by changing the polarity notation across this 2 ohm resistance and indicating voltage across this resistance. Now using Ohm's law we will calculate current through this branch. I is equal to 6 volt divided by 2 ohm. It will become 3 ampere and the direction of current will be downward direction. Modify the network by indicating current of this branch. Now on this node we know the value of all entering currents, but the leaving current is unknown and we are interested to calculate its value, so we can apply Kirchoff's current law on this node to calculate the value of current IA. For that purpose write KCL equation for this particular node. Currents of these 3 branches, which are 3 ampere, 4 ampere and 2 ampere, are coming towards this node. So all of these will be taken as entering currents, 3 ampere plus 4 ampere plus 2 ampere, while only one current is leaving from this node, that is IA, and it is taken with minus sign. Add these values together, their sum will be equal to 9 ampere, and place this minus IA on the other hand side of equal to calculate its value, that will become 9 ampere. So the value of this constant current source inside this network is 9 ampere. So this was exercise problem number 2.94. Thank you. See you again in next video.